Welcome back. This is another video of our introduction. In the previous video we talked about Docker and why it's useful for data engineers. We also took a look at how we can create air quotes pipeline and put it in Docker. Now we know what Docker is and how to use it. Now we will run Postgres in Docker and we will put some data to this Postgres. And for putting the data there, we'll use a simple Python script. So let's start. This is where we finished last time. We have two files. We have a Docker file and we have pipeline. And now we want to get some practice with SQL and we want to run Postgres. And we can use this Postgres for practice in SQL before we run the SQL queries in BigQuery later in the course. To run Postgres, we will use the official Docker image of Postgres. You can just look it up. What we can also do is for week 2, we will use Airflow, and Airflow internally, we will talk more about what Airflow is and why do we need this. But Airflow internally uses Postgres, and we can take a look at what's the image we use there, and we can just reuse that. So I think right now the code is in branch. So we are interested in this. So you will see this code in action in the week 2. We will talk about Docker Compose. So Docker Compose is a way of running multiple Docker images. We will talk about this in the next video. I want to copy it and I want to use it for running Postgres locally. Let me copy it. Then I open Visual Studio Code in this directory. Now I want to come up with a command that we need to run in order to have Postgres running. Remember, to run something in Docker, we need to do docker run. Then also we do -it to be able to stop it. Then we see this, we have image, it's Postgres 13. So this is the image and the version. And we need to configure Postgres. So for Postgres, for configuring Postgres, we need a bunch of things. So these are environment variables. So this is a way of configuring whatever we have in a Docker container. So in this particular case, we want to say what the user will be, or what the password for this user will be, and how we want to call our database. So these are environmental variables. Let me copy them. And to set environmental variables, when we run Docker with docker run, we just need to use -e flag and then say what the parameter for this particular variable should be. I'll just use root for the user. Then for password, I'll also use root. And then for the database name, I will use ny-taxi. So because this is the name of the dataset we will use for practice in SQL, and this is the dataset we will use throughout the course. We'll talk a bit about this dataset later, but I will call the database ny-taxi, New York taxi. So that's one part of the configuration we need. There is other part we need, this volumes part. So this volumes is a way of mapping folder that we have in our file system on the host machine to a folder in the container. And because Postgres is a database, it needs to keep files in a file system if we want to be able to save records there. So it will go physically save this record in its specific format to a file system, and then later it will also go there to read this record. And if we do this in Docker, remember Docker doesn't keep the state. So next time we will run, the state will be lost. We don't want that. We want, when we next time run Postgres, we want to make sure that our data is still there. So that's why we need to map a folder we have on our host machine to a folder in the container. And this is called mounting. And let me create a folder. I'll call this folder ny-taxi Postgres data. And now I will map this folder to this folder on the container. So for this, for mounting, we use this -v flag, and then we have the path to the folder on the host machine, and then we use colon to say to which directory on the container we want to map it to. We actually need to do one more thing. I'm not sure why it's not mentioned here. We also need to specify the port. In order to access the port, we need to map a port on our host machine to a port on a container. This is needed to send requests to our database, because for database we will send SQL queries to this database and then it needs to reply with answers. So we need to be able to access a specific port of Postgres, and this port, if I remember correctly, is 5432. And so we map a port on our host machine with this number to a port in the container. That's all the configuration we need. It will not work because Docker needs a full path. So since I'm on Windows, I need to use this long path, and they actually need to use the Windows way of setting the path. So instead of /c, I need to start with C:, and then the rest of the path. So I need to have the full name, the full path, the absolute path to the folder. On Linux, on macOS, I would do something like current directory like this, pwd. I can do that here as well, pwd, but this returns a Unix-like path, and Docker and Windows will not like this, and it will complain that it cannot find this path, whatever. So yeah, for Windows, you need to do it this way, and if you're on a normal operating system, so you can just do this pwd. Let's run it. Hopefully it will work. Okay, I must be running something on this port, probably another instance of Postgres. So let me do docker ps. So this is something that is still running from my previous experiments. Let me quickly remove that, and I'll cut this part out because this is not interesting for you. So see you soon. I stopped the container. Let me check what is running again. Nothing is running. This means I can run this thing again. So let me do that. I think it's running. So let's see what happens next. And because it's running for the first time, it needs to do some initialization. When we run it for the second time, I think it should be faster. Okay, and now it says database system is ready to accept connections. It means that we can actually start working with this. I'm not sure what that is. I will just ignore that. I hope it's working. So now I can take a look at what is in this folder, ny-taxi Postgres data. So this is the folder that we mapped to a folder in the container, and we see that Postgres created some stuff there. I have no idea what it's doing exactly. This is some internal representation of data for Postgres. Let's not look at this. And now we can try accessing this database. Let me create another terminal window. And now I want to run a CLI client for accessing the database. The client I use is called pgcli. This is a library in Python. You can install it using pip install pgcli. I think if I run it, it will tell me that it's already installed. It says requirement already satisfied, so it means I already have it. You probably don't, then you just do pip install pgcli, and then I can use this CLI to access a database and then run some queries there. So let me just run it. It will output help. Okay, I think I need to see help. I think I need to do maybe -- help. Yeah. So this is what we need to specify in order to log into the database. So let me do pgcli. Then we'll start with host -h. Host for us, it's localhost. Then -p, I think it's port. We don't need to specify it because this is the standard port from Postgres, or we might as well specify it because why not? Then username. So for us, user -u is root. This is what we specified here. So user, password, and database. So this is what we specified. For database, I think it's -d, and then it's ny_taxi. I don't think we need to specify anything else here. So let me just run it. Now it will ask for, okay, for you probably it will ask for password. I have already accessed this pgcli on localhost for root, so that's why it didn't ask me. I assume for you, you will get a password prompt and you will need to type the password for root, which in our case will be root. So you type this in and then you will get something like that. We now connected to Postgres and we can run some queries. We don't have anything there yet, so all we can do is look at a list of tables that is available in our database. There is nothing because of course we haven't created anything. Or we can do something like select one, and then it will give us a response with just one column, one row, one there. Not super useful, but at least we can test the connection to the database and we can see that it's working. What we will do now is we will take a look at the data set we will use for this course, and we will take this data set and load this to our Postgres. I'll open another terminal window, and in this window I will run Jupyter Notebook. If you installed Python using Anaconda, you already have Jupyter. If you installed Python differently, then you can do pip install Jupyter, and then you will have it. I already have it, and to run it I will do Jupyter Notebook, and I will get access to Jupyter, because now I want to use Python to be able to read the dataset and load this dataset and put it to Postgres. So I want to use Python for that, and Jupyter is a convenient interactive environment for doing this. You don't have to use Jupyter. You can use, for example, Visual Studio Code, or you can use PyCharm or whatever you want. I just prefer using Jupyter, and that's why I will use it as well. So we have Jupyter right now. I will create a new notebook here. By the way, you can ignore this. So if you just installed Jupyter, you will probably have only one kernel here. It doesn't matter when you create a new notebook. Click here on Python 3, and we have this window. First, let's check if we have pandas. Oops, it should be PD, not SPD. Yeah, so we have pandas. The version of pandas I have is 1.3.4. Let me also rename it. I will call it upload data. Your Jupyter might look differently. It's because my header is hidden and my toolbar is hidden as well. This way I have more space for recording videos, but for you it looks a little bit different, so that's fine. Now we have that, and now let's take a look at the dataset we actually want to use. There should be a link in our repo. This is the link. Okay. So there is an article in Medium. This is not the link I was looking for. I'm actually looking for, let me just go to Google and write taxi data. And yeah, so this is the link I was looking for. Let me copy it and I'll put this in the repo as well. So this dataset contains taxi trips from New York City. There are actually 2 datasets or even 3, like yellow taxis and green taxis. Don't know what is the difference between these two. And we have quite a lot of data here. And for this lesson, we'll take this thing here. So it's yellow taxi trip records from January 2021. And I will click copy link and address. And what I will do, let me actually open yet another terminal window. So now I will use wget for downloading this CSV file. What you can do, you can also just right click on this and do save link as, for example. On Windows, you do not have it by default. You will need to download this. I already have it. It's a very convenient command line utility for downloading things. I will now use it for downloading the CSV file. I don't know what is wrong with my internet. It's quite slow, but I actually already have it. I don't need to download it. I'll just copy it from a different location. I have it. So you can pretend you didn't see this and I downloaded it. So I have it. And we can take a first look at this dataset using less. So less is another command line utility for looking at text data. And we see that in this CSV file we have a bunch of fields. So the first one is vendor ID. Maybe actually we should use like Excel or something else for looking at this data. I have LibreOffice Calc, which is an Excel-like program. Let me use it for opening this file. It's quite a big document actually. Let me stop it. So what I'll do is in Linux there is a very convenient command called head, which outputs only first let's say 100 rows of a data set, and then so it just outputs first 100 records, and then I can save it to a different file using this command. So I can say yellow head CSV, and then now I will stop it because it will kill my computer, and I will open a sample. This sample should be a lot faster to open because it's just 100 rows. And by the way, we can also take a look at the number of rows using this vc-l command. Vc is word count, minus l, instead of counting words, it will count lines. So vc-l means count how many lines are there in this file. So there are 1,300,000 something rows. So it's quite a large data set, I would say. So that's why LibreOffice, it was a bit slow when opening all this. And we needed to help it a little bit by taking only the first 100 rows. Let's take a look at what we have here. So we have quite a few columns. You know what? We actually have a document that describes exactly what each field is. So I'm looking for this yellow trip data dictionary. I will also copy this link to our repository, and this link tells us what exactly each column means. So it says that vendor ID, this is who is the provider, operator of the taxi. Then this pickup date time, drop off date time is when pickup happened, and then the drop off happened. These are timestamps. How many passengers are there? The distance, I think it's miles probably. Yeah, miles. Then rate code ID says what exactly it is. This one, PU, it's pickup location ID, DO, drop down location ID. So it says where the passenger was picked up and where they were dropped off. We actually also have this data, this taxi zone lookup table, and that's another CSV file. Let me just open it. For this customer, so they were picked up in this location. So let me quickly find. They were picked up in Manhattan on Lincoln Square East, and then they were dropped off in location 43, which is Manhattan Central Park. I don't know if it's far or not. Maybe they could have walked. Yeah, so this is the type of information we have, and a bunch of other things. There are quite a few columns. Another interesting one for us could be this total amount or tips, how many tips they gave to the driver. This is how the data set looks like. So this document describes what exactly we are looking at, what kind of columns are there, and it's helpful to make sense of this data. So we took a look at the data. Now let's load this data with pandas. Don't worry if you don't know pandas. Actually, if you want to learn more about pandas, you can go to a different course that we also run in Datadog Club. This course is called Machine Learning Zoomcamp. And in the first week of this course, in the introduction, we had a video about pandas, and you can check it out. This is module 1, lesson 9. We will not go into details. We will just need a few comments there. Pandas is just a convenient way of dealing with tabular data. CSV file is a tabular data, so that's why we'll use it. For reading data, we will use read CSV command, and then we just need to specify that we want to read this particular data set. I don't know what this warning is. I didn't want to read the entire data set in memory, and that's quite large. So I also wanted to say that I want to read only the first 100 rows. So then reading the first 100 was quite fast. And we see that we have the same data as we saw in our LibreOffice. So now what we can do next is take this data set and put it to our Postgres. For that, we need to first generate a schema. This is an instruction like create table that specifies what kind of columns are there, what kind of types are there, and so on. For that, in pandas there is a module called IO, and in IO we have another package SQL, and then in SQL we have this thing called getSchema, and we can actually use this function to convert the data frame we have, this df thing, to a DDL, data definition language. Is a part of SQL that is used for specifying schemas. So this we will have it. Yeah, we need to specify the name of the table. So let's say the name will be yellow taxi data, for example, data. We haven't created a table yet, so this just prints a statement for us to see how the statement will look like. You see that we have this /n things, so these are line breaks. Jupyter doesn't print them, that's why we need to use this print function. Now we have this statement. So this is a statement in so-called DDL, data definition language, which describes how the schema, the table, should look like in SQL. One thing we can see immediately is that for pickup date time and drop off date time, it actually uses text. It shouldn't use text because pandas doesn't know that this is actually timestamp. We need to tell pandas that this is a timestamp. Yeah, in pandas there is a function called toDateTime that takes date in string and parses it and creates a datetime object. It's pickup time. Yeah, and you see that now the type here is datetime 64. Doesn't matter what 64 is, but we see that this is a datetime, which is good because this is what we want to have here. For the rest, it's not a super optimal schema because it uses real for total amount, so we actually need to use decimal, but for our purposes here this is fine. So the only issue we have here is that we need to say that these two fields are timestamps, and we will do this by parsing them with pandas. And now we also need to write them back to the data frame, and this is how we do it. Okay, so now we parsed these columns as timestamps and wrote them back to the data frame, and now when we generate this statement, we will see that these two are timestamps now. This statement, I'm not sure if we can just copy this and paste to Postgres. Maybe it will work, maybe it will not. So we actually need to generate this DDL statement, this create table statement, in something that Postgres will understand for sure. So for that, we need to tell pandas that we want to put this into Postgres, and then it will generate a statement that works for Postgres. So for that, we actually need to create a connection to Postgres, and then it will see, okay, this is a connection to Postgres, and then it will generate a statement that is specifically for Postgres. And we will need to have this connection anyways to be able to write data to our database. So let's do that. Pandas uses a library called sqlAlchemy. This is a Python library for dealing with SQL. This is what it uses, so we need to install it. I already have it. I think it's a part of Anaconda. So when you install Anaconda, you have this sqlAlchemy. If you don't have Anaconda, then you just do pip install sqlAlchemy. I think you'll need to double check. I'm pretty sure this command will work. So let's import this. So we need to import this create engine, and now let's have engine. So for us it will be create engine, and then we will need to specify the type of the database we have. For us, the type of database is Postgres, so we need to write PostgreSQL, the full name, and then we need to specify the user, which is root, then the password, and then we need to say add the host name, the local host, and then the port is 5432, and then the database name is nytaxi. Let me check. Yeah, it's nytaxi. Looks correct. Let me check if it actually works. It didn't complain. What happens if I type something wrong here? Yeah, it also doesn't complain. Maybe I need to run this connect. Okay, and now it says something is wrong. Yeah, password authentication. And if I put the correct credentials, yeah, now it works. Okay, I just deleted the cell. I pressed the X key, so I just pressed it. Now we need to specify the connection. So connection is the thing we just created. And now we have the definition in Postgres dialect. That one would have worked. I'm not sure if Postgres knows what real is and if it treats it as float. Maybe it does, maybe it doesn't, I don't know. But this is the statement that Pandas will execute when it will try to create this table. Yeah, I think now we are ready, so we know what to do. We took a look at the data. We see that we need to parse only this thing. And the rest, it's not ideal, but it will work fine for us for this video. And later in other lessons, in other weeks, we will see how to define these types properly. Actually, we only read the first 100 rows. We want to read the entire data frame. The entire data frame is too big. We don't want to insert 1,600,000 rows at the same time to our database. I don't know how it will react. So that's why we need to batch it, to chunk this CSV file into smaller batches, and I will use iterators from Pandas. Iterator allows us to chunk the CSV file into smaller data frames. For that, I think we need, yeah, so we have this iterator true, and then there is chunk size. To see help, what I do is I do Shift Tab, and then I see this help. Chunk size, let's say 100,000 rows at once. So we will break our CSV file into chunks of this size, and then we will read them one chunk at a time. And then for each chunk, we will put the chunk to database, and then after 16-17 chunks, the entire dataset will be in our database. So I'll call it df_iter, meaning this is an iterator. If I do this, if I print it right now, it shows that this is not a data frame, this is an iterator. And to get the first value, I'll do next. Next in Python, this is a function that returns the next element in an iterator. So now I thread this. So I have this data frame, and the size of this data frame is exactly 100,000, like we specified. And we need to do these two things here to make sure that this is timestamps. So let us do that. And then now we will generate this statement, and we will create a table. For that, what we can do is we can just do data frame head. And yeah, data frame head returns the first 5 records, the first n records. We can specify whatever many rows we want. If we specify n0, it will only return the header. And now we want to use that to insert all this data, meaning there are no rows, only the table definition to our database. What will happen effectively when we do this? We will only execute this create table, but we will not insert any data, because we are doing it in chunks. So first we want to create a table and then insert the data chunk by chunk. In this data frame, there is a method called toSQL, and what this method is doing, it's inserting. So if I do connection this engine and name, what's the name? yellow taxi data. So now what it will do, it will go to our database and insert all the rows. So first it will create a table and then insert all the rows. That's why we only want to have the first part and insert rows separately. And another thing we need to specify here is what happens when a table with this name already exists. You can see that there are multiple options. So fail, replace and append. So first we will replace, means that it will see if a database with this name already exists, then it will drop it and it will create a new one. And if a database with this name doesn't exist, it will not do anything. Actually, I wanted to do this only on the column names. So I only want to create a table. I do not want to insert anything yet. So it executed successfully. So now let's see what kind of tables we have. So now this /dt returns a list of tables. This yellow taxi data, and I think we can also do describe a table. I think desk is from MySQL. Let's just need to do d yellow taxi data. Wrong slash. Okay, yeah. So we now see that this was the schema that we created, and now we can finally put some data to this table. Yeah, we will execute the same thing, but without this head 0. And then if exists, instead of replacing, we will use append. I think it's append. If exists, it will append, insert new values to the existing table. So this is exactly what we want to do. And we want to do this for each chunk of the iterator. You can actually time it. This time thing will tell us how much time it actually took to run this line. So it took 10 seconds, and now we can do count. Actually, yeah, select count from, what was the name? From yellow taxi data. It will tell us how many rows we have in our table. And we see that we have 100,000 rows as expected. So now what we need to do is we just need to insert the rest of the data frame to our table. I will use, maybe it's not the cleanest code. When I do this data frame next, I will get the next chunk, and then I want to do it in a loop. And then the way iterators in Python work is when you no longer can get next, it will throw an exception. It will say there is no data anymore, and our loop will exit this. That's why I'll have an infinite loop here, and then I will take next chunk until there are no chunks left. And then for each such chunk, I will first do this thing, and then I will insert data to our database. Just to have some visibility into what's going on, let me add some print statements. All right, inserted another chunk. And we can also measure how much time each chunk takes. So I'll do from time, import time, poor man's benchmarking, do t-start. This returns the current timestamp in seconds at the beginning and then at the end. And then if we subtract start from the end, then we will know how much time it took. We'll write it took that many seconds. And now we will just do the subtraction. So this notation here, if you're new to Python, it means that it will treat it as float and it will have 3 decimal digits after. You will see right now. So now we are inserting data to our table. I hope there will be no mistakes. Okay, yeah, the first chunk, we can check already that, yeah, so now it's 200. Yeah, and it will take some time now. I will not wait now till it finishes. It will take a bit of time because now we are done with this video. So we run Postgres using Docker. We run it locally, and then we were able to connect to this database. Then we took a look at the data that we will use throughout the course, and then we started putting this data to our Postgres database. So what we will do next in the next lesson is we will use a special tool called pgadmin to be able to connect to our database. This is quite convenient. This is more convenient than using this pgcli, and this is exactly what we will do in the next lesson. So see you soon.